All right, this is 7.3, hypothesis testing for the mean with small samples. This is going to feel a little bit similar to 7.2, except for we have smaller samples instead of large samples like we did before, which means instead of using the z, we're going to be using the t-chart. Critical values in a t-distribution. If n is not 30, so it's smaller than 30, but the sample is still normal, you may use the t-distribution, where you find your degree of freedom by doing n minus 1. So for all of these, you're going to be looking at the t-chart instead of the z-chart because your n is too small. It's smaller than 30. But it does state that your information is normally distributed. So t distribution is for anything smaller than 30. Z is for anything bigger than 30. So let's look at the steps. Number 1, you're going to determine the level of significance, which I've been calling that Jesus fish. Number 2, you'll have to find the degree of freedom by doing n minus 1. And number 3, you'll use the table to find the critical values. So again, the table we're looking at is the t-chart, not the z-chart. For left and right, you're going to use the column that says 1 tail. So the t-chart is way easier than the z-chart because you don't have to do 1/2 or 1 minus or anything like that. All you have to do is flip to the chart and look at the column that says 1 tail. Now, if you're asked for a left tail, you will have to add a negative sign to the number because we know that everything that is left-tailed is negative. If it's right-tailed, you'll look at the 1 tail column, but you'll keep that number being positive because we know that everything that is right-tailed is positive. If you see it has 2 tails, you'll look at the column labeled 2 tails, and you'll take both the negative and the positive because we know that you have to have 2 scores or 2 numbers for something that's 2-tailed. So again, there's no 1/2, there's no 1 minus. All you have to do is look for the correct column, either 1 tail or 2 tail. So let's try one. It says, find the critical values, t sub 0, for a left-tailed test. So it's going to look like this. Left-tailed, I know it's going to be negative, with a level of significance of 0.01 and n being 14. So I have everything set up. The next thing I need to do is find my degree of freedom, which would be 14 minus 1, or 13. Now I'm going to turn back to my t-chart. Okay, it's on page A18. I'm going to look down at the degree of freedom where it says 13. I'm looking at 1 tail with a level of significance of 0.01. So I'm going all the way down to 13 to find 2.650, and I know it has to be negative. So my t sub 0 would be negative 2.650. All right, let's try another one. This one says, find the critical value t sub 0 for a right-tailed test. So I know it's going to be positive, with a level of significance of 0.10 and an n of 9. So again, smaller than 30. I know I have to use t. I need my degree of freedom. I'll do 9 minus 1. And now I'm going to look at the back of the chart. I'm looking at 1 tail. I'm looking at 0.1 and a degree of freedom of 8. I find it is 1.397. And it stays positive because it's a right-tailed test. The next one says, find the critical values negative t sub 0 and t sub 0 for a 2-tailed test. So I'm going to have 2 answers, negative t sub 0 here and t sub 0 here, with a level of significance of 0.05 and an n of 16, smaller than 30, so I know I have to use t. Find my degree of freedom, 16 minus 1 is 15. Now I'm going to look at the back of the chart. At this time, I'm looking at 2 tail, I'm looking at 0.05, and then I'm going all the way down to 15 to find it is 2.131. So I would have negative 2.131 and positive 2.131. So at this point in time, you would stop the video, you'll do this assignment, and then we'll meet tomorrow. Tomorrow you'll pick up with the second set of the notes. If you want to just go all the way through and finish them today, you can, but this is where I have asked you to stop. So this portion begins the second part of 7.3. So if you had paused it yesterday, this is where you will pick up. So it says the t-test for a mean where your n is smaller than 30 and your s is unknown. So if this is the case, your equation will be t equals the sample mean minus the hypothesized mean all over the standard error. Let's write this out in symbols too on here. That would be x bar minus my mu over s over the square root of n. You would also need to find your degree of freedom, where your n is minus 1. So again, this looks the same as the z equation, but we know that our n is smaller than 30, therefore we're plugging it into t instead. Remember that when you make a decision, there's a chance that there could be a type 1 error or a type 2 error. So just be aware that that is a possibility, and we reviewed those in the last section. So let's try another one here. This says an insurance agent says that the mean cost of insuring a 2008 Honda CR-V is less than $1,200. So I'm going to start off, I need to make my H sub O, my H sub A, and I need to determine which one is the claim. I'm talking about the mean for each. I know H sub A is the only one that can have equal to on it. It says is less than $1,200. Less than $1,200. That's going to be my claim. So the opposite is my H sub O, greater than or equal to. Okay, a random sample of 7. So right away I should know that I have to use t because my n is smaller than 30. Has a mean cost of 1,125 and a standard deviation of 55. Is there enough evidence to support the claim at a level of significance of 0.10? Okay, so I'm all set up. Now I'm going to plug into my t equation. T is x bar minus my mean all over the standard deviation over the square root of n. So take a second and plug that into your calculator. Let's see what we get. Okay, so if I look at this one, I notice that here I'm going to be left-tailed because it's pointing to the left. So I know that this has to be negative. Okay, and I find that the t that I'm testing is here. So now let's find my rejection region using this, and I know it's left-tailed, so I know it's going to be negative. So I'm going to look at the back of my chart. I'm looking at one tail, 0.1, Going down to 6, because that's my degree of freedom, I see it's 1.440. Okay. Forgot my negative there. Okay, so negative 3.61 is definitely over here somewhere, so it is in my rejection region. Therefore, I am going to reject H sub O. And if I throw out H sub O, the claim is the only thing that's left, so I would say enough evidence to support the claim. So make sure you answer all parts of that question. All right, let's try another one here. It says the company also claims that the mean conductivity of the river is 1,890 milligrams per liter. So start by laying out your H sub O and your H sub A. This has to be equal to, and I know I'm talking about the mean. Okay, it says is 1,890, so that has to be this one. So the opposite would be here. So right away, I know that I'm looking at something that's two-tailed. So I'm going to need a negative T and a positive T. The conductivity of the water sample is a measure of the total dissolved solids in the sample. You randomly select 19. So just to confirm, we are using the T. If I can find my degree of freedom. The sample mean is 2,500 and the standard deviation is 700. Is there enough evidence to reject the company's claim at 0.01? Okay, so I'm going to plug it into my T equation so I figure out which one I'm looking at. So I need x bar minus my mean over the standard deviation over the square root of n. So again, go ahead and work it out. Okay, so I know I'm looking at positive and negative. So now I'll look at the back of my chart. Okay, I'm looking at two-tailed. I'm looking at degree of freedom of 18, and I'm looking at a level of significance of 0.01. I'm going all the way down and I find 2.878. So where does this fall? This falls over here. So I am going to reject H sub O, okay? And if we reject H sub O, then we also reject the claim because we're throwing it out. So a little bit of a different question there. They asked if there was enough evidence to reject the claim, and there was. So using p-values. Suppose you wanted to find a p-value given that t was 1.98 and the degree of freedom was 15 and it was right-tailed. You look at the table 5 in appendix B, which is the table we've been looking at. You can figure out that p is going to fall between these two, but you can't find the exact value for p. That's why we haven't been using the p-test. We've been using the rejection regions instead. Whoops. Okay, so it's easier for us just to use those rejection regions because we cannot find that exact value. So if we look at number 6, it says, another DMV claims that the mean wait time is at most 18. So I'll set up H sub O, H sub A, I'm looking at the mean. H sub O can have equal to, it's at most 18, so it can be 18, but it cannot be more than 18, so this is going to be my claim. So I know that it's going to be right-tailed, looking at this. Okay, so I'm going to take positive. A random sample of 12, which means my degree of freedom is 11, has a mean of 15 and a standard deviation of 2.2, level of significance of 0.05, assume the population is normal. Okay, so we can use those rejection regions again. We don't have to use the p-value. So can plug it into my t equation, x bar minus the mean over the standard deviation over the square root of n. So now I'm just going to be plugging things in here. Okay, so now I'm going to look at my right tail. I'm looking for something positive, and I'm looking at 0.05 and my degree of freedom of 10. So I'm looking at my chart. And I see it's 1.812. This is clearly outside, so I would fail to reject. But I'm not necessarily supporting the claim. All right, so that's the end here. You should have already completed this part, so you have one last little part on 7.3 to complete here.